Page 2 of the packet of slope field problems is a page in which we have a matching activity in which we are asked to match the slope field graph with equations provided of original functions. There's a couple different ways you can do this. You can think of the slope field itself and what a solution curve through that slope field would look like. Then match the solution curve up with the equations, the original equations, or you could take the derivatives of these equations and then match them up that way to the slope fields, because remember, the slope field is simply a picture of the slopes of the derivatives at infinitely many points in the plane. So let's maybe try to match it up that way. Sometimes you end up doing a little bit of both. So if we think of the first one, number 7, I'm going to probably do number 7, 8, 11, and 12 with you, and then I'm going to leave the rest of them with you to do. So if you think of number 7, the derivative of that, of course, is simply 0. So what we want to be looking for is, of our graph choices, which one has slope cuts where all the slopes are 0. Well, I think that's pretty obvious. It matches up to D. All right, let's try number 8. We have y equals x. If we think of the derivative is simply going to be 1. So we want to match that up with a graph where it looks like all the slope cuts have a slope of 1. Well, that looks to be h. Let's try number 11. We could do the derivative of this. If we do that, we get negative 2 over x cubed. So this one's a little bit trickier. So one thing you could think of is, in terms of the slope field, it's not going to be defined for an x value of 0, depending upon whether the given x that you would be substituting into this differential equation is either positive or negative. That could cause you to obtain either a positive or negative slope. So you are going to have a slope field in which, number 1, you know it's not going to be defined for 0, and you're going to have a mix of positive and negative slopes. So that rules out a couple of them. We've already used D and H. I think we can narrow it down to A and G. So one option is you could simply substitute in a number, like 1 or negative 1 or something like that, and see which one might fit better between A and G. Well, if you do that, you find out that graph A matches it better. Number 12, nice trig function. Derivative of sine, of course, is cosine. If you take a look at our graph options, sine and cosine curves, of course, are pretty easy to identify. And just looking at what we have here, it looks like we might have a couple options, either here in B or here in E. So it's probably going to come down to those two. We just need to figure out which one. So this is one place where it might be beneficial to think of what the solution curve might look like through the given slope field. So over here at E, remember, when you draw a solution curve through a slope field, you're going to kind of follow the slope curves. If we try to do this one up here, so between the two, we'd want to try to figure out, does one of these curves look like the sine function we're given? Well, between the two, it kind of looks like E could be. So perhaps E is the answer. One way to double check is if we were to choose values to substitute into x in the derivative. So for instance, 0. Cosine of 0 we know to be 1. So that means on the correct slope field, where x is equal 0, the slope should be 1. And it definitely looks like right here we have slopes of 1 where x is equal 0. So it's a pretty good bet that the correct answer for that one is E. I'm going to leave you to try the remaining 4 problems. Answers will be provided for you online.